In the world of amateur radio, a ladder filter is a critical component used primarily in super heterodyne receivers and SSB or single sideband transmitters. Ladder filters can be made of inductance capacitor combinations or crystal capacitor combinations. Crystal ladder filters have very low insertion loss due to high Q, that is quality factor. Small capacitors are placed between the crystals or in parallel to ground. By changing the value of these capacitors, you can squeeze or stretch the bandwidth of the filter to suit your needs. Think of it as a high precision gatekeeper for radio frequencies. Its job is to allow a very specific narrow band of frequencies to pass through while aggressively blocking everything else. Crystal ladder filters are constructed using a series of quartz crystals connected in a chain-like or ladder configuration, often with capacitors between them to ground. Selectivity. Because quartz crystals have a very high Q quality factor, they can create an incredibly sharp cutoff. This prevents signals from adjacent frequencies from bleeding into your conversation. The ladder shape, the name comes from the schematic layout where the crystals and capacitors resemble the rungs and rails of a ladder. Primary applications. 1. Intermediate frequency filtering. In a receiver, the incoming radio signal is converted to a lower fixed frequency called the intermediate frequency or IF. The ladder filter sits at this stage to reject interference. It strips away splatter from nearby high power stations. Defined bandwidth. It determines whether you are listening to a wide signal like AM or FM or a very narrow one like Morse code or CW. 2. SSB generation. In a transmitter, a ladder filter is used to create a single sideband signal. It takes a double sideband signal and literally chops off the carrier and one of the sidebands, leaving only the narrow slice of frequency needed for efficient voice communication. 3. DIY homebrewing. Hams love ladder filters because they are cost effective. While professional mechanical filters can be expensive, a radio amateur can buy a bag of cheap microprocessor crystals, example 4.915 MHz or 9 MHz, and build a high performance filter for just a few dollars. The performance characteristics of a well-designed ladder filter is measured by two main factors. Shape factor. How vertical the walls of the filter are. The steeper the walls, the better it rejects unwanted signals. Insertion loss. How much the desired signal is weakened as it passes through the filter. Ideally, this should be as low as possible. For a CW filter, typical bandwidth is 250 to 500 Hz. That's meant for Morse code and is very narrow. SSB filter is 2.1 kHz to 2.8 kHz and meant for voice communication. AM filter bandwidth is 6 kHz or more and it is meant for high fidelity audio.